Hi friends, this is question number 8, exercise 4.3 pertaining to quadratic equations. This says a train travels this says a train travels 360 km at a uniform speed. If the speed had been 5 km per hour more, it would have taken 1 hour less. For the same journey, find the speed of the train. In this case, we have been given that the train is moving with a uniform speed and it is covering a distance of 360 km. It further says if the speed of the train would have been 5 km per hour more, then it would have taken 1 hour less. Naturally, when the speed is more, time taken will be less. Now here key parameter is the time. So if the same distance train travels at a certain speed that is unknown to us, let us assume the speed of the train be x km per hour, which you have to find out. Then how much time it is going to take, and when the speed increases by 5 km per hour, then what will be the time taken, because the difference of these two timings is given as 1 hour. So in this case, we'll find out the timings for the both the cases and we'll take the difference of that, which is equivalent to 1, and then we'll solve the equation. So here let us assume that the speed of the train be x kilometers per hour, and we know that time is equal to distance by speed. As we know, speed is equal to distance by time, so time will be equal to distance by speed, because we have taken the time on the left hand side and speed has come in the denominator side. So time has become distance divided by speed, and the distance traveled is 360 kilometers, and speed we have assumed as x kilometers per hour. So time t1, let us say it is going to take t1 as the time in the first case when the speed is x kilometers per hour and the distance is 360 kilometers. So t1 is equal to distance by speed. So distance is 360 divided by speed is x. So this will become equation 1. T1 is equal to 360 by x. So this is equation 1. In the second case, what happens? Distance remains same, that is 360 kilometer, and speed becomes 5 kilometers per hour more. So speed in this case will be x plus 5 kilometers per hour, as x was the speed in the case 1, which has increased now by 5 kilometers per hour, so it has become x plus 5 kilometers per hour. So time, let the time be t2 in the second case. So t2 will be equivalent to distance divided by speed, that is distance is 360 divided by speed is x plus 5. So this is equation 2. Now we have been given in the question the difference of time in the first case and second case is 1 hour. When the speed is increasing in the second case, naturally the time will be less, and that is given. The difference in timings is given as 1 hour. It will take 1 hour less in the second case. So we'll say T1 minus T2 is equal to 1. So we'll put the values of from the equation 1 and 2 above for T1 and T2, and we'll be getting 360 divided by x minus 360 divided by x plus 5 is equal to 1. Now this has taken the shape of equation we have to solve it. Now we'll take 360 as common. So within the bracket we will be getting 1 by x minus 1 by x plus 5 bracket closes is equal to 1. So within 360 is outside we have taken, and within the bracket if we take LCM, so LCM will be x into x plus 5. So when we are multiplying 1 by x with the LCM, that is x into x plus 5, we will be left with x plus 5, as x and x will get cancelled. So this will give us x plus 5 here, minus here we will be multiplying by x into x plus 5, and x plus 5 and x plus 5 will get cancelled. We will be left with x. So this will give us minus x divided by LCM, that is x into x plus 5, and bracket closes, this is equal to 1, or this is further equal to 360, let it be as it is. So within the bracket x and x will get cancelled, we will be left with 5. So this is 5 divided by LCM is x into x plus 5 within the bracket. So if we multiply inside, this will become x into x, x square plus 5x. So this has come x square plus 5x is equal to 1. Or further simplification will give us 360 into 5, 1800 divided by x square plus 5x is equal to 1. And now on cross multiplication, this will become 1800 is equal to x square plus 5x, because x square plus 5x is dividing here. So on the right side, if you are taking, this will get multiplied by with the 1. So we will be getting x square plus 5x here. Or further, x square plus 5x, 1800 we take on the right hand side. This becomes minus 1800 is equal to 0. So now we will solve it. This is a quadratic equation which we can solve by using the quadratic formula or by factorization method. So I am using a factorization method. You can also try with the formula method. So factorization will give us 1800 divided by 2 will give us 900. And if we divide it by further 2, it will give 450, then again by 2, this will give 225. Again we'll divide it by 3, this will give us 75. Again 3, it will give 25. So 5 into 5, 25. So this is the factor of this one. So if we know, we have to factor in such a way that sum should be 5x and the multiplication of the two numbers should be 1800 x square in minus. So product should be in minus and the sum should be positive. So if you try different factors like that, 2 into 2, 4 into 2, 8 into 3, 24, And remaining, if you take remaining 15 into 5, 75. 75 and 21, that is 54 is a gap, but we require only 5x. So then we can try another one. So this will give us, say, 5 into 3, 15, 15 into 2, 30, 5 into 3 into 2, 30, and 5 into 3, 15 into 3. So that is also not give us 5x because difference is very high here. So we require 5. So 5 into 3 into 2, 5 into 3 into 3, that is 5 into 3, 15 into 3, 45, and 5 into 2, 10 into 2, 20 into 2, 40. Any 45 and 40 will give us the right breakup. So plus 45x and minus 40x will give us plus 5x, and product is obviously will be minus 1900x square. So we can write it as it is: x square plus 45x minus 40x minus 1800 is equal to 0. Or this we can write as x square, so nothing can be taken out common here, plus 45x minus 40 we will take common. Inside that we will get x is 1800 and 40 we are taking common. So inside that we will be getting minus 45. So here we could have taken common x, we could have taken common, or we will take common x is equal, inside the bracket we will be getting x plus 45, and here we will take minus 40, inside the bracket x plus 45 will be getting is equal to 0. Because if you could have taken plus 40 common, then this could have become minus, and this could have become minus 45. So this will not tally with this thing, left hand term which is common. So x plus 45 is common here, x plus 45 is common here. So this becomes, on further simplification, x plus 45, that is common from both the terms. So here we will be getting x, and here we will be getting minus 40 is equal to 0. Because two terms are multiplying and the product of the product is 0. This can be possible, either one of the terms is 0, either this first term or second term is 0. So we'll say either x plus 45 is 0. When this is 0, then x is equal to minus 45. We are taking 45 on the right hand side, so we will be getting minus, or x minus 40 is equal to 0. So x is equal to 40. So 40 kilometers per hour is the speed. This is minus 45 kilometers per hour. But speed cannot be in minus, so speed has to be in positive only. So x is equal to 40 kilometers per hour is the correct answer. So that we can cross verify also. So when the speed is 40 kilometers per hour, then T1 is equal to, in equation 1, 360 divided by speed, that is 360 divided by 40, that is 9 hours. Time will be, T1 will be 9 hours. When speed goes up by 5 kilometers per hour, it means it becomes 40 plus 5, 45 kilometers per hour. Then the time taken will be T2 is equal to 360 divided by 45, as already we computed in equation 2. So 360 divided by 45, that is 8. So T1 is 9, T2 is 8. So T1 minus T2 is 1 hour. So that is given in the question also. So it means our answer is correct. So this is cross verification of the answer, whether it is correct or not. In such type of questions we should verify, so that will be better in the exams. So that will give us assurance that our answer is correct. So in this case, the speed of the train we have to find out, and the speed is x. X is 40 kilometers per hour. We can write speed of the train which is nothing but speed of the train x. So this we have to find out, and this is over now.